In this episode, we will be covering all of Java's data types, string buffer, and all of the loops. So let's get started. First off, we have the byte, which stores numbers between -128 to a +127. Next, we have the short data type, which can store numbers a bit larger, from between -32,768 to +32,767. And then after those two, we have the integer, which can store over 2 billion in either negative or positive direction, as well as long, which is the long data type, and it can store absolutely massive numbers, as long as you put an L at the end of the number, because otherwise it will just be treated as an int, and even my IDE is underlining it red. So if you're using the long number for any reason, just remember to put an L at the end of the number. But all of those number types can only really store full numbers, and in Java there is also some data types which can store fractions, such as float and double. Floats can accurately store for up to 6 or 7 decimal places, but you have to make sure that at the end of the number, at the end of your float number, you will add the letter F. The same thing does not apply to doubles. As you can see, you can just leave them without any letters at the end, and doubles can actually store up to 15 decimal digits accurately. If you try to store anything more detailed than that, you're gonna have issues, so just try to stay in that range. Now there is only two more primitive data types to cover, the first one being Boolean. Booleans can only store true or false values, as well as the character data type, which, as you can probably guess, stores a single character. Now the next data type is not actually considered primitive, because that data type is an object itself, and it is string. Strings can store text made of multiple characters, and as you can see, the definition of the string data type is actually started with the capital letter S, which is a convention in Java to make objects start with the capital letter. As you can see, our main function actually starts with the letter M because it's a class. And as we discussed before, classes are just templates to producing objects. The string data type offers some options which you can choose from, some methods. If you type in the name of your string and then the dot operator, you can see that there are some operations which you can perform on strings, such as you can just ask for a character at a specific index, you can ask it for text between specific two indexes, or even capitalize the whole string. However, strings in Java are not as flexible as in some languages, because you can't update characters at specific locations in a string. So for example, if I wanted to update this capital S to be the letter X, I'm not able to do that with a regular string. However, Java has a method to deal with this issue, and that's called the StringBuffer. This is how you would define a new string buffer, just like in the previous episode when we were creating new objects. Here we are creating a new instance of the StringBuffer object, storing it in the text variable, and to the constructor of our string buffer, we're passing a string that says, I'm better now. And this string buffer is what allows us to manipulate strings in way more ways, such as changing a specific character, just like I said we couldn't do with the regular string. That can be done through the setChar@, method, which takes in an integer for the index of the letter you're trying to change and the character which you want to put in the original one's place. String buffer might offer you more options than just the regular string. However, it also takes away some of the flexibility the regular string provides. For example, you can't actually update the text to a new one if you try. As you can see, I can't simply replace the text that's currently there. You can perform different operations on the text, you can append the text, or you can even remove some letters, or even change the length of the string. However, you cannot just replace the string with another one. So if you need an actual variable for a string that's going to be constantly changing to something else, then I would advise you to just use regular strings. There is one more data type we have to cover, and that is the array data type. And the reason I left it for the last is because every single data type you already see on the screen can be turned into an array by simply adding brackets after the data type. So for example, if I would like to create an integer array, I would type in int and then open and close square brackets and continue with my definition as usual. However, now after the equals sign, I would open and close curly brackets, inside of which I would define my actual integer array. As you can see, it will be storing 5 integer numbers, and you can do the same thing with, just like I said, every single data type you can see on the screen, including the string buffer. And not only that, but if you make your own objects, you make your own classes, you can actually make arrays of those classes and those objects as well, not just the predefined ones. Accessing a specific index in an array is simple. You just use the name of the array, and then in square brackets you type in the index which you would like to access. In this case I typed in index 3, so this would return as the integer 4 because it's on the third index. Remember that indexes start at 0. And that would be it for the data types. So now let's get on with the loops. The first loop we will cover is the while loop, which can be defined as follows, with the condition being in the brackets. Here I defined my while loop to continue on running while our b value is greater than 0, which just means that until our b value is lower or equal to 0, this loop will never stop running. So let's do something about that. Let's add the system printout. As you can see, this time I actually typed system.out.print instead of print line. And the only difference is that if I use print instead of print line, it will not create a new line after the end of the string, so that it's going to print everything on a single line. After that, I will decrease the value of b by typing b minus minus. And if we run the program now, as you can see on the console down below, it started counting from 100 until it reached 1, because then the value of b became 0 and it was no longer greater than 0, so the loop stopped executing. The next loop in line is the so-called do-while loop, which is exactly the same as the while loop with one exception. Do-while loop actually executes the code inside of the loop once first and then checks the condition of the loop, where the regular while loop never starts executing if the condition is not met. The do-while loop will always execute at least once, even if the condition is not being met. The syntax of the do-while loop is as follows. As you can see, you just start with the word do, open and close square brackets, after which you put in your regular while syntax with the condition in the bracket, and then you finish it off with a semicolon. Inside of our loop, let's just do the same thing we did before. And if we run the code, as you can see, it runs exactly the same as it did before, from 100 to 1. However, now we can show the exception by changing the sign so that our loop should only run when b is lower than 0. However, we know that b is 100, so the condition is not met. With a regular while loop, this code would never execute. However, because this is a do-while loop, if we run it, as you can see, it runs a single time, printing out 100, and then also changing the value of b to 99 because of our b minus minus command. So that were while and do-while loops. Now the last loop I want to cover is the for loop. For loops are defined as follows, with 2 semicolons separating the bracket into 3 sections, and each of those sections has its own function. The first section in the bracket is the definition section, which means it's basically code that will be executed a single time at the start of the loop, and it's usually where you define a new variable to iterate over inside of the loop. Let's say we will create an integer I, and at the start let's set it equal to 50. Then in the second section of the condition, you set the actual condition. So let's say we want our loop to run while our I integer is greater or equal to 0. You would just define it with the greater or equal than symbol. Now the third section is the code that actually gets executed at the end of each iteration, which means it gets run after all of the code inside of the loop. This is where we're going to put our I minus minus, which will keep decreasing our I until it's no longer meeting the condition and it will break the loop. Inside of the loop, let's just do our regular print line, printing out I, and if we run it one last time, as you can see, our loop works perfectly. It prints out every number from 50 down to 0. Thank you very much for watching. I hope you enjoyed it, and I hope you will tune in for the next time.